Okay, everybody, I've started the recording. Can I get a Gucci in the chat box? Yes, Gucci or Prada or LV if you want. Just type something in the chat box so I know you are alive and I know you're not dead. You're not being forced to take this class by your parents or by your friends. Oh my god, they're making me take the class. Ah, no, 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 no. I don't want that, huh? Yeah, Prado. No, not Prado. I mean Prada. So the chat is disabled. Okay, Hava. I'll enable it for you guys. Sounds good. Now it's enabled. Now everybody can type in the chat box. WS Omar, hi Halima, walaikum salam, walaikum salam. Okay, let's quickly go over what we've done up until this point, right? So, up until now, we started off with the concept of an atom, and we said that literally an atom is the basic unit of matter, and we discussed this in quite a lot of detail. And forgive me if if you feel like I'm repeating myself so many times, but in order to clarify your conceptual misconceptions that your teachers have imparted in your brains, I have to repeat myself a lot of times to remove the kharab chemistry that has been imparted to you, right? So an atom is the basic unit of matter. That's what we studied, and we studied that matter is effectively anything which has a mass and occupies space. So if you look at yourself, you have a mass, you occupy space, your matter, the TV, the laptop, your bodies, your iPod, your iPad, your chargers, everything around you has mass and occupies space, and therefore it's matter. And the teeny tiniest particle which will make matter up, and that's called an atom, right? You can't see it with your naked eye and whatnot. And then we studied the concept of an element, and we discussed how the world was created and then how we discovered the atoms and whatnot. But now we will streamline to the O-level IGCSE curriculum, right? So we talked about what an element was. What was an element? Element was literally a pure substance made up of identical, not identical. I told you guys that I'll talk about the word identical in chapter number 2. I don't like to use it in O levels and IGCSE. You can use it, but I, instead of saying identical, I just say one or same type. So an element is literally a pure substance that is made up of one or same type of atoms, right? So if the same type of atoms, or if one type of atoms, they're there, and it's obviously a pure substance, that's going to give you an element, that's going to form the element, right? And we looked at the periodic table, and I literally showed you that the periodic table is known as the periodic table of elements because every substance in the periodic table is, number one, a pure substance, and number two, they all are made up of the same type of atom. So if I talk about lithium, it's an element. Why is it an element? Because of two reasons. Number one, it's a pure substance, and number two, it's made up of the same type of atom. So a block of lithium is made from lithium atoms. It's made up of the same type of lithium atoms. But a block of beryllium is an element. Why? Because it's a pure substance and it's made up of the same type of atoms. Which atoms? It's beryllium atoms. If you talk about magnesium, why is it an element? Because it's a pure substance and it's made up of the same type of atoms. Which same type of atoms? Obviously magnesium atoms. So that's how we defined an element. And then we also talked about a compound. So a compound formed when you had two or more elements chemically combining together. It's obviously a pure substance. A compound is also a pure substance. What do we mean by pure substance? I'll talk about that in chapter number 2. But a compound is a pure substance which is made up of two or more elements chemically combining together. Chemically combining literally means that there's a reaction, a new product forms. Just like I gave you the example in the last class, that if you take sodium metal, it's obviously a very reactive metal. If you take sodium and place it on the palm of your hand, it'll burn through it. If you take chlorine, it's a poisonous gas. Chlorine is a poisonous gas. If you inhale it, it can also kill you if you inhale a lot of chlorine. It was actually used in World War I. So it's a poisonous gas. But if you take sodium and chlorine, these are two elements, but if you combine them, if you chemically combine them, it gives you something known as sodium chloride, which is your namak, which is the salt, the edible salt that you eat in your day-to-day life and that you use in your dishes and whatnot, and in your biryanis and pakoras and samosas, right? So you realize that sodium was a very reactive metal. It's an element. Obviously chlorine was a very, it was a poisonous or a toxic gas. But when they chemically combined, which means when a new product formed, formed, it was actually called as compound, because obviously this is a pure substance and it's made up of two elements chemically combining. Why am I saying it's chemically combined? Because something new is being made. And you'll understand this chemically combined term and pure term in their respective chapters. But for now, just understand that chemically combined literally means that something new is being formed. There's a chemical reaction that took place. So if I talk about, SO2, or if I talk about H2, if I talk about calcium, can you differentiate between the three, which of these are compounds and which of these are elements? Obviously, if you look at SO2, it is obviously a compound because it has one element here and the other element here. So it has two elements. Please realize that there are not three elements. There are no three elements. There are two elements. One is sulfur and one is oxygen. You don't have three elements. What does this 2 mean? This 2 literally means that you have two atoms of oxygen combined with one atom of sulfur. So there are three atoms, one sulfur and two oxygens, but the elements are two. So can I say it's a compound? Absolutely I can. I can literally say it's a C. C for salt. C for sui, like Ronaldo says, right? So it's obviously a compound. Right? Why? Because there are two elements. It's a pure substance, number one, and there are two elements chemically combining together. Sounds good? And then when you look at calcium, calcium is literally found in your periodic table right here, and it literally says the periodic table of elements. So if you talk about the periodic table of elements, calcium is in fact an element. Why? Because number one, it's a pure substance, and number two, it's made up of a single type or one type of atoms. Single type of atoms. It's made up of one type or single type of atoms, which is in fact what? The calcium atoms. It will only contain calcium atoms. It will not contain any other atoms. That's why it's a pure substance. Sir, is it only made from one atom or one type of atom? Kashif, one type of atom. There, in a block of calcium, there may be billions and billions of atoms, but realize that all of these atoms will be calcium atoms. That's why I'm saying that calcium is an element, because all the atoms inside a block of calcium are gonna be of the same type. The type is calcium, calcium, calcium. Sounds good? And then if you look at, H2, you might say, sir, this is a compound because it needs two elements, blah, 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 blah. But realize there are not two elements here. There's only a single element called hydrogen. Yes, there are two atoms of hydrogen, but it's a single element. Two atoms, but a single element. So what is this? This is obviously an element. Why? Because it's a pure substance, number one, and number two, it is made up of the same type of atoms or a single type of atoms, which is the hydrogen atom. If you realize, you might say, hey sir, there are two atoms. Yes, there are. Two atoms have combined together, but they're both of hydrogen. So the type of atom is the same. That's why hydrogen is an element. Similarly, nitrogen, fluorine, chlorine, bromine, iodine, you might see all the twos here, but all these two does not take away from the fact that all of these are elements, because although you may have two nitrogens, but they are both the atoms of nitrogen. Although you may have two fluorines, but they are both fluorine atoms. Although you may have two chlorines, but it's the same type of atoms, which are chlorine atoms. So realize that all of these are elements, and you can also find more about them when you study chapter number 3. We also call them as molecules. So they're elements as well as molecules. We briefly discussed the definition of molecules, which was two or more atoms combining together. Two or more atoms chemically combined. That's what we talked about when we talked about molecules. So there are two or more atoms. If you have two or more atoms chemically combined, it's going to be called a molecule, right? It's going to be called a molecule. It does not matter that these atoms are same or different. It does not matter. The atoms can be of the same type or it can be of different type, as long as there are two or more atoms chemically combining. So if you look at O2 is also an element. You know, it has 2 oxygen atoms. It's the same type of atom. All these 2, 2, 2, 2, 2, they are all elements because they have the same type of atoms. And if you look at SO2, now SO2 is not an element. What is SO2 or SO3? It's not an element. What are these two? These two are compounds. Why? Because it has 2 different elements chemically combined. 2 different elements chemically combined. So H2O is also a compound, right? But when you start to define compounds and elements, also take into account molecules. If you look at the definition of molecules, it's just like 2 or more atoms combined together. That's it. That's what a molecule is. The proper definition of a molecule, you'll learn more about that in chapter 3. But for now, just realize molecule is whenever you see 2 or more atoms, you can call it a molecule. Be it the same atoms or different atoms, if you see 2 or more atoms, it's going to be a molecule. So can I say that nitrogen is a molecule? Can I say nitrogen is a molecule? Yes. Can I say nitrogen is a molecule? Absolutely I can. Absolutely I can. Why? Because there are 2 atoms combined. That's what a molecule is. But can I also say that nitrogen is an element? Can I also say that nitrogen is an element? Yes, because it's a single type of atom. So realize a particular substance or a particular chemical can also be an element and it can also be a molecule. Similarly, a compound can also be a molecule. A molecule, you know, it's just like if something is a compound, there is a possibility that it's also a molecule. And if something is an element, it's also a possibility that it's also a molecule, right? So realize if something is an element, that does not mean it can't be a molecule. It's not it will always be a molecule, but if something is an element, it may also be a molecule. If something is a compound, it may also be a molecule, right? So you need to clarify these concepts. So if you look at fluorine, it's also an element and it's a molecule because there are 2 atoms combined, 2 Fs, 2 Cls. So it's an element because you have a single type of atom, and it's also a molecule because there are 2 atoms chemically combined. Bromine. But if you look at SO2, is SO2 a molecule? Is SO2 a molecule? Yes, it's also a molecule. Why? Because you have 1, 2, 3. You have 3 atoms combined. Is SO3 a molecule? Yes. Why? Because you have 1 and 3. You have 4 atoms combined. Is H2O a molecule? Yes. Why? Because you have 2 hydrogens and 1 oxygen combined, right? So these 3 are molecules, but if you now look at them closer, you can also call them compounds. Why? Because there are 2 different elements, sulfur and oxygen, hydrogen and oxygen. Make sense, everybody? So any element with 2 atoms combined can be called a compound? No, Aisha. Any element with 2 atoms can be called a molecule, not a compound, because nitrogen is not a compound because it's a single element. It does not have 2 elements. It's just nitrogen, right? Make sense? Easy peasy lemon squeezy. Easy. Please hold on about monoatomic. Please forget about the chemistry that you've learned up until now. What do you mean with 2 atoms? Kashif, 2 atoms, it means these 2 nitrogens, 2 Fs, 2 Cls, 2 Brs, 2 Is, 2 Os, 2 oxygens and 1 sulfur, 3 oxygen and 1 sulfur. There are a lot of atoms here. Makes sense? Okay, so today we'll start off with the first chapter, which is states of matter. This was just an introduction to everything. Now, it's Fe, Arush, Fe is an element. F and E are not separate things. It's just a symbol for iron. Look at this, Arush. Fe is right here. It's a symbol for iron. It's not something, it's not, F is not an element and E is not an element. Fe combined is just a symbol for iron, Arush. So it's an element. Yeah, iron is not a molecule because it's just Fe. Fe is the symbol for iron. If iron, if for example nitrogen is here, if nitrogen is combined with another nitrogen atom, then it will be N2. Then you could call it nitrogen molecule as well as nitrogen element. FeCO, these are not different elements. It's just CO is the symbol for cobalt. It's a single element. That's just the symbol. The first chapter takes about 7 classes, Alina, and after the first chapter, every chapter is for 3 classes, 3 or 4 classes. The concepts are for 3 or 4. The first chapter is the lengthiest, and the first chapter, yes, only the first chapter is the lengthiest because I need to fix your basics. That's all. That's the only reason why the first chapter is the lengthiest. See, we've already spent 3 classes on just introduction to chemistry. We just need 4 more classes for the first chapter. Done? Okay, and then we'll just do practice for all the years from all the past papers. Okay, states of matter. Now, what does this mean? This means that whenever you have matter, what is matter, everybody? Matter is anything which has a mass and occupies space, like we discussed, right? So whenever you have matter, it has different states, which means it has different forms. And what are the 3 forms of matter that we've studied? I'll give you an example. What are the 3 forms of matter that we've studied throughout our elementary school? It's solid, it's liquid, and it's gas. Now realize that there are other forms of matter as well. You also have, ionized plasma, you also have quark-gluon plasma, Bose-Einstein condensate, and fermionic condensate, and a lot of these gibberish and bougie words, technical words. But it's not a part of your course, neither in your O-levels nor in your A-levels. So just realize that, so you have solid, you have liquid, and gases as the 3 states of matter, which means what? That anything which has a mass and occupies space will have 3 different forms, can have 3 different forms. One is solid, one is liquid, and one is gas, everybody, right? And I can show it to you, and I can also give you an example. For example, you look at ice. It is literally H2O. It is matter. It's H2O. Ice is H2O. First of all, can you guys tell me, is it a compound, or is it an element, or is it a molecule? What is ice? Is ice a compound, an element, or a molecule? Everybody's saying a compound. Everybody's saying it's a compound. It's a compound. It's a compound. Who said this? Hava, can you please DM me your Easy Pesa account? You've officially won 500 rupees. Hava is saying, sir, it's a molecule as well as a compound. Because realize that something which is a compound can also be a molecule. Why is it a molecule? Because there are 3 atoms combined. And if you have 2 or more atoms combined together, you can call it a molecule. So H2O is a molecule as well as a compound. Why is it a compound? Because it has 2 elements chemically combined. And why is it a molecule? Because you have 3 atoms chemically combined. That's it. So Howard, do message me your Easy Pesa, and don't put question marks, guys. Whenever you're answering stuff, please try to avoid question marks and be very, very straightforward with your answers, because that's how you learn more. Instead of being confused in everything and putting question marks, just say your answers. And if you're wrong, it's okay. You're all here to learn. So it's fine. So ice is H2O. I'm telling you that. Maybe you didn't know it, but ice is H2O. So is it matter? Is ice matter? We realize that it's a compound as well as a molecule, but is ice matter? Is ice matter? Yes, it's matter. Why is it matter? Because it has a mass and occupies space. And what does this chapter revolve around? What does this chapter revolve around? This chapter revolves around the states of matter, which means it revolves around the different forms of matter. Now, ice is actually an example where matter, H2O, is in a solid state. Is in its solid state, right? So ice is matter and it has solid state, right? We've seen it. We've studied this throughout our elementary classes. Similarly, if you look at water, it's also matter. Why? Because it's H2O. Can I call it a compound? Yes, because there are 2 elements chemically combined. Can I call it molecule? Yes, because there are 3 atoms chemically combined. So I can call it a molecule. I can also call it a compound. Is it matter? Yes. Why? Because it has mass and occupies space. And it's the same H2O. It's the same matter we're talking about. We're talking about H2O here. We're talking about H2O here. It's the same matter. It's the same thing. But it has a different form when we talk about water. What is the form of water? Water is in the liquid form. Literally. How easy. And then we talk about steam. So steam, once again, is matter. Why? Because it's H2O, and H2O has mass and it literally occupies space, And can I call it a compound? Yes. Can I call it a molecule? Yes. Why compound? Because it's a pure substance made up of two elements chemically combined. Why a molecule? Because there are three atoms chemically combined. Easy. How easy is this? And so steam is basically the same H2O and it's in its gaseous state. So realize that whenever you have matter, it can have three different states. It can have solid state, it can have liquid state, and it can have gaseous state. And we've all studied this throughout our elementary classes. Now the question is, and the question that you guys should all be asking is very, very crucial, which you may have not been encouraged to ask before, but I always want to, build this idea of questioning in your brains. You guys should question and ask me, sir, why is ice solid? Why is water liquid? Why is steam gas? This should come in your brain. It's very, you might, think to yourself, oh my God, it's such a silly question if I ask why is solid a liquid, why is ice a solid, why is water a liquid, why is steam gas? It's such a silly question. But you guys should ask, because in fact, it's the most genius question that anybody could ever ask. And the reason behind ice being solid or water being liquid or steam being gas is something known as the kinetic particle theory. And after we understand the kinetic particle theory, you'll be able to understand why ice is solid, why water is liquid, and why steam is a gas. Muhammad Maz Munir, is this Sir Maz, the CS teacher? Maz, let me tell you guys, yes, bilkul sir, aise. Let me tell you guys something. Maz has been my student. He scored a distinction in computer science. I taught him in 2022. He got an A star in chemistry, alhamdulillah, and he has officially joined us as a computer science teacher. So if you guys are interested in computer science, or if your parents are forcing you to start with the field of AI, सरमाज इज़ द बेस्ट मैन टू गो. मुझे कसम से कभी कन्वर्जन सर समझ नहीं आई थी, बट आफ्टर टेकिंग सर्स यूट्यूब. सर व्हाट इज़ योर यूट्यूब? कैन आई ऐड इट हियर? कैन यू टेल मी योर यूट्यूब? बताएं सर. अब सरमाज आप बताएं मुझे अपना यूट्यूब. कोड कैटलिस्ट. सो दैट्स सर's यूट्यूब, you know. So do check it out, you know. I always encourage young blood. I always encourage all of you guys. It's not necessary that you all come into the field of teaching, but whatever you do, just be the best at it. Sir, wait, what is his age? Sarmaz, आपकी क्या उम्र? आप तो sir is I think 22 or 20. मैं बुरा हूँ, मैं बड़ा हूँ. Okay. चलो, that's 42. Sir is also 42. मैं भी 42 हूँ, sir भी 42 है. चलो, sounds good. अच्छा खैर, सर आप मेरी क्लास डिस्टर्ब कर रहे हैं. अच्छा चलिए, बैक टू क्लास. चलो, ऑसम. चलिए सर, इंशाल्लाह ये सारे बच्चे आपको देखेंगे, फिर आपकी यूट्यूब को फॉलो करेंगे. चलो, ओके, थैंक्स मास, बाय बाय चीते, बाय. खैर, so I think you guys should all ask me, and you should also ask yourself why ice is a solid, why water is a liquid, and why steam is a gas. And the reason for that is, to understand this, you first of all need to understand something known as the kinetic particle theory. Now, what is the kinetic particle theory, and what, in fact, does it hint to you guys in order to understand this beauty? Why is this? Why is this? Why is this? Well, the kinetic particle theory says a lot of things, but I'll only state the portion which is a part of your course and which will help you understand the above. Kinetic particle theory says that all matter, whatever matter is made up of, whatever, be it atoms, be it tiny particles, be it molecules, be it whatever matter is made up of, the smallest particles, the teeny tiny particles, are gonna be in a constant random motion. That's what it says. So what it basically means is, if you take H2O, water, a cup of water, if you take a cup of water, it's obviously matter. And the teeny tiny particles, called the H2O molecules, are gonna always be in a constant random motion. If you take a block of sodium, or a block of ice, or whatever, right, a block of sodium which is solid, right, the teeny tiny particles of sodium are gonna be in a constant random motion. If you take steam, if you take farts, if somebody farts, sorry girls for being disgusting, but if a boy farts, he's stinky, stinky, binky. But if somebody farts, it's obviously gonna be very, very stingy if the person has digested something containing sulfur content, because that's what makes the fart stink. But sorry guys, sorry. So the teeny tiny particle which makes up farts are gonna be in a constant random motion, and this motion actually determines whether something is gonna be a solid or a liquid or a gas. We'll discuss this in more detail, but this is the motion. It's the motion which actually determines whether something is going to be solid, liquid, or gas. But not just the motion. There's also something else. It's the motion as well as the arrangement. Remember this. It's the motion as well as the arrangement of particles which would make it either go into the solid state or the liquid state or the gaseous state. Now, before we discuss the motion and arrangement, which actually results in the three states of matter, yes, Arush, you're right. So before we actually look into the motion and arrangement, which results in solid, liquid, or gas, first of all, I want you guys to tell me a few things by just looking at solids, by just looking at liquids, and by just looking at gases, So, can you guys tell me the shape of, and let me see if I have a better, let me see if I have a better picture for it. I first of all want to, talk about certain properties through observation. Certain properties solids, liquids, and gases have through observations. Before I go into motion and arrangement. See, realize that the reason why a chair is a solid, is because the particles, the teeny tiny particles which makes up chair, have a certain motion and have a certain arrangement which results in a chair being a solid. The reason why water is a liquid, it's because the teeny tiny particles which makes up water have a certain motion and an arrangement which would result in water being a liquid. And the reason why farts are gases, or why steam is a gas, is because the teeny tiny particles which makes up this steam have a certain motion and a certain arrangement which would result in steam being a gas. Now the question is, sir, what is that motion? What is that arrangement? Before I talk about that motion and that arrangement, I first of all want to talk about solid, liquids, and gases by just looking at them, right? So, if you look at the shape of solids, my question to you guys is, do the shape of solids change? If you're looking at a table, the next day you come and you look at the table, the table is no longer a table. Does it convert into a mirror or does it convert into a chair? No, it's the same. It's there. So if a solid table is in front of you or a solid iPad is in front of you, does it keep on changing its shape or is it the same? Unless you break it, that's something else. But when you don't chedify it, is it the same? It's not going anywhere. So can I say that solids have a fixed shape? Can I say that solids have a fixed shape, everybody? Absolutely, I can say it. Absolutely, thank you. So I'm going to say that solids have a fixed shape. And you can also call it as definite shape. Sounds good? Okay. Then, if you talk about the liquids, do liquids have a fixed shape? And I always love to quote Bruce Lee here. Do you know what Bruce Lee said? Bruce Lee said, don't be like solids, everybody. Be like liquids. Be like water. Because if you put water into a jug, it becomes the jug. If you put it into a jar, it becomes the jar. If you put it into a cup, it becomes the cup. If you put it into a cylinder, it takes the shape of the cylinder. So realize, be flexible. That's what he meant. Zainab, that's what he meant. He meant to be flexible, for people to be flexible. So do liquids have a fixed shape, everybody? No, absolutely not. The shape of fixed liquids is never fixed. Why? Because it takes the shape of the container. The shape of the container. Whatever you put it into, it'll take that shape. But if you take a table and you put it into a jar, a big jar the size of a table, it'll still remain a table. If you take a table and put it into a container, it'll still be a table. It'll still have the same shape of a table. But liquids are not like that, right? That's what we observe. I want you guys to observe these things. And then, if you look at the shape of gases, do gases have a fixed shape? Do gases have a fixed shape? No, they don't. Their shape is also not fixed, because if you fart inside a room, the gas particles are going to take up the space of this entire room. If you put the same gas into a syringe, it'll take the shape of the syringe. If you take the gas into a container, if you fart inside a container, it'll take the shape of that container. Sorry girls for being disgusting, sorry. Honestly, it is what it is. So here, the gases' shapes are also not fixed. Now, if you look at a solid, let's suppose I take a solid cube, a solid cube. Like, for example, Rubik's Cube. If I take a Rubik's Cube, can you guys actually calculate its volume? You've studied this in mathematics. Length into length into length. You can calculate the volume of a Rubik's Cube. Length into length into length. Does it change or is it fixed? Unless you break it, that's something else, kiddos. But in normal circumstances, it's fixed. It's fixed. So solids, they in fact have a fixed volume, or you could say a definite volume. Okay, forget about slime, Zainab, for now. I'll talk about slime later on. Khair. So, if you talk about solids, they have a fixed volume. And then, if you talk about liquids, now some of you guys may think that liquids do not have a fixed volume. If you put into a cup, it becomes a cup. If you put it into a jar, oh no, you dumbo, that's the shape. So, the way I like to explain this is, I always say, take a glass of water. Let's suppose you put 10 milliliters or 10 centimeter cube of water, or let's suppose 100 centimeter cube of water. Let's suppose you put 100 centimeter cube of H2O. 100 centimeter cube of H2O in water, inside a cup, right? Now, you take a jug, a big fat jug that looks something like this. Sorry for my drawing, but I'll put a heart on it. Yes, you took a jug and you took 100 centimeter cube of water and poured it inside a jug. Did it become 200 centimeter cube? ऐसे तो फिर Africa's water crisis has been solved. If this is the case, then Africa's water crisis has been solved. Take a small cup of water, put it into a jug, and it'll become more water. That's not possible, is it? So if you take 100 cm cube of H2O inside a cup and you start to pour it inside a jug, will it become 200 cm cube or will it stay the same? Will it still be 100 cm cube of water? The only thing that will change is the shape. First, it took the shape of the cup. Now, it'll take the shape of the jug. But the volume of water remains the same. So, the volume is fixed. This is where most of the students, get mistaken. So, the volume is fixed. But gases, if you look at gases, देखो, if you fart inside a room, it will first of all take the shape of that room, because the gases, they don't have a fixed shape, right? But it will also take up the entire volume. It will also take up the entire space. And so the volume of gas is going to increase inside a big container compared to a small container. That's why small containers have more pressure and big containers have less pressure, because in big containers you have more volume of gas being occupied, but in smaller containers the gases occupy a smaller volume. So it depends on where you fart. If you fart inside a small washroom, it'll take that it'll take that space up and it'll have that volume as well. But if you fart inside a big room, it'll have a bigger volume, right? So gases volume is not in fact fixed. Make sense? Sorry guys for the disgusting example. You can give examples of perfume instead of art. Sorry Hawa, I'll talk about perfumes in the next batch. Agle saal, next year, hopefully. Achha, then let's talk about compression. What is in fact compression? Dekho, compression is basically reduction. That's what compression is. It's reduction. But reduction in what exactly? Reduction in what exactly? For that, I'll have to show you how solids, liquids, and gases look on a very molecular level. So if you zoom into a chair, and you zoom into a table, and you zoom into steam, chair, water, or steam. If you zoom into a solid, the particles look something like this. If you zoom into a liquid, the particles look something like this. And if you zoom into a gas, the particles look something like this, right? Now, if you look at solid particles, can solid particles be compressed? That's the question. Can solid particles be compressed? Now, what is compression? It's the reduction, but it's the reduction in volume. Remember, it's the reduction in volume. And why would volume reduce? Because of spaces between particles. So compression is actually the reduction in volume. And why would the volume reduce? It would reduce because there are spaces between particles. So compression is the reduction in volume because of spaces between particles. Now try to understand this. Look at a solid. Literally that's how scientists figure it out as well. If you look at the solid particles, can you see spaces? No, I can't. Please don't count this as a space. It's just flawed drawing. But are there spaces between solid particles? No. So can solids be compressed? Compression is the reduction in volume because of what? Because of spaces between particles on a very molecular level. So can I say that solids can be compressed? Absolutely not. So we say that solids are incompressible. And the question is, why are solids incompressible, everybody? Why are solids incompressible? Yes, because there are no spaces. Yes, Alina, absolutely true. No spaces. No spaces between what? Between the solid particles. Please realize, no spaces between solid particles. The examiner can ask you these questions, please. So the reason why solids are incompressible is because there are no spaces between the solid particles. Now if you look at liquid particles, can you see spaces? Can you see spaces between liquid particles? Yeah, I can. I can see spaces. Look at this beauty. Space, 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 space. So liquids in fact are compressible. Liquids in fact are compressible. But you know what we say? We say that liquids are also incompressible. Oh, that's such a beautiful statement. Sir, you are contradicting yourself. You literally said that compression is the reduction in volume due to spaces between particles. So if I apply force here, the solid particles are not going to, move closer together because there are no spaces. But if I provide force to a liquid, the liquid particles, because there are spaces between these liquid particles, you can actually compress them, sir. I can literally see these spaces. So if I apply force, these particles are gonna come closer together and the volume of the liquid is gonna be reduced. That's what compression is. It's the reduction in volume. So why are you saying it's incompressible? Because kiddos, the force that you need to bring these particles close together is so high that we say that even liquids are incompressible. And that's why I like to use the term almost. So if the examiner asks you this, always put in bracket almost, because if you go on to pursue science as a career, you'll realize that liquids can in fact be compressed, but there are very high forces required. Very, very high, Alina. Very high forces required. So that's why we say to reduce the volume of a liquid, you need a very, very high force. That's why we also state that liquids are incompressible. Almost incompressible, right? तो इधर मैं क्या लिखूंगा? Liquids are also almost incompressible because there are little to no spaces between the liquid particles. And then look at gases, my beautiful farts, not my farts, but sorry, my beautiful perfume. How I'll talk about this in the next class. Please write this question down. How I think why is such a huge force required? It has to do with something related to a gluing force. And I'll talk about that on Monday. Mohammad Ahmad is saying, what does compression mean? Mohammad Ahmad, Zulekha Marthi ki aurat, compression is what? The reduction in volume when a force is applied. And why would the volume be reduced? Because of spaces between particles on a very, very micro level. So if you zoom in, what is compression? It's the reduction in volume. after a force is being applied. And why would a volume be reduced? Because there would be spaces between particles. Solid, incompressible. Why? No spaces between particles. Liquids, almost incompressible, because there are little spaces, little to no spaces between particles. And then gases, look at these beautiful gases. Oh, perfumes. Gases, compressible, incompressible. Gases are in fact compressible. So if I apply force, would the volume of gas be reduced? If I apply force, let's suppose this was a piston and I pushed it inwards, would the volume of gas be reduced? Yes, it would absolutely be compressed. So can I say that gases are compressible? Absolutely I can. So I'll say, hey, gases are compressible. What does this mean? This means that there can be a reduction in volume for gases if force is applied. And why? The question is why? The examiner can ask you this. He's never done this, but he can. Why? Look at the gases. Look at the structure of gases. Why? What is the structure of gases? Structure of gases. Look at the particles of gases. Why can gases be compressible? Because there are lots of spaces. Yes, because there are lots of spaces between particles. You know, you can bring these particles close together by applying just a little force, because there are already lots of spaces between particles. So why are gases compressible? Because there are spaces between what? Between gas particles. Please, you need to note all of this down. The examiner can ask you these things. Hanya is saying because they are far and apart. Hanya, it's correct, but then again, your marking scheme requires you. I'm giving you words of the marking scheme, the key phrases, the key words. They are far and apart is right, but you need to understand that in order to explain compression, you need to talk about the spaces between particles. So it's better to just say, how can they be compressed? Like in what way? Arush, you just apply force to it, and the particles, they come closer together. Why? Because there were already spaces between particles. So there's enough room for them to come closer together. There are no questions regarding calculating compression. No calculations. अच्छा किसी बच्चे ने बहुत अच्छा सवाल पूछा. Let me see. Hold up, guys. Please don't DM me, because then I can't read the questions in individual DMs. It becomes difficult for me. Okay, chalo. Last concept. Density. Let's talk about density. So density is how much mass something occupies in a certain volume. This is what you learn later on in physics, right? So that's what density literally is. How much mass can be occupied in a certain amount of volume. And it's pretty easy. Just look at the structure. Just look at the solid particles. Let's suppose this is a solid, and I'll take the same volume of liquid, and I'll take the same volume for gases. Let's suppose the volume is the same, right? Let's suppose this green volume, and this yellow volume, they're all the same. Let's suppose that's all 10 cm cube. Can you guys tell me which of these would be most dense? Would a solid in 10 centimeter cube be most dense? Would a liquid in 10 centimeter cube be most dense? Or would a gas in 10 centimeter cube be most dense? Which of these three would be most dense, or the densest? Which of these? Obviously solids. Why? Because in the same amount of volume, a solid packs more particles. There are more particles, and the more particles you have, the more mass you pack. And what is density? It's mass over volume, the amount of mass you pack in a certain amount of volume. So if the volume is same for every, but the mass is greater for solid, that means that the density for solids would be greater, because if the numerator is greater and the denominator is the same, then the answer that you're going to get is going to be greater. So for solids, let's suppose mass was 20 grams, let's suppose, and for liquids it became 15 grams, and for gases it became 2 grams, let's suppose. The volume was same, 10 cm cube for solids, 10 cm cube for liquids, and 10 cm cube for gases. So we realize that solid, liquid, and gases, the difference is that solids are they have the highest density, liquids have the second highest density. It's lower than solids, but greater than gases. And then gases are the least dense, or they have the lowest density. Why? Because if you take the same amount of volume for all these three, a solid packs in more particles, which means it will pack in more mass. So why do solids have the highest density? Because it has more particles in the same volume, right? And that's why it will have a greater mass, a higher mass, and therefore it will have more density. Is this a part of your course? Did you need to know these 3 points? No. Your physics teacher should teach you this. But what if the amount of liquid is more than the amount of solid? Then what? Zainab, I'm making sure that the volume is the same. So if the volume is same, if the volume, can I take a screenshot? It's a good question, Zainab, but realize if I'm saying that this is 10 cm cube, this is 10 cm cube, this is 10 cm cube, I've made sure that the volume is same. And then inside this 10 cm cube, I realize that there are more solid particles. See, you can even see it here. There are a lot more solid particles than the liquid particles, and you could even count them. And then in the same 10 cm cube, the number of gas particles are lower. So the lower the particles, the lower the mass, right? So you can't have more amount of liquid in the same volume. If the volume is the same, solid particles are going to always be more than the liquid particles, and liquid particles are always going to be more than the gaseous particles for the same volume. Makes sense, everybody? So that's what we've done up until this point. We've literally figured this out. So there are certain properties through observations: fixed, not fixed, not fixed, 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 not fixed, incompressible. Why are solids incompressible? Because there are no spaces between solid particles. Why are liquids almost incompressible? Because there are little to no spaces between liquid particles. Why are gases easily compressible? Because there are large spaces between gas particles. Large spaces between gas particles. Large spaces between gas particles, right? That's why it can be compressed. What is compression? The reduction in volume by applying force, right? Density is how much mass something packs in certain amount of volume, and solids will always pack more mass because solids have more particles for the same amount of volume. Can you repeat? This is least, kiddo. This is least or lowest. Sorry for my pathetic handwriting. Least. Can you explain a little bit about plasma, just out of curiosity? Alina, the time is unfortunately over and my team is waiting for me. You can DM me for this and I'll talk about it. And you can even go on to YouTube if you're actually curious about all the other states. For now, I not suggest going into it because you won't understand a thing. It'll just waste your time. So for now, let's just focus on solid, liquids, and gases. And inshallah, after you're done with your A levels, you can look into plasma and become a big scientist, a very great scientist. So I think this is the last demo class because Friday, Saturday, Sunday, chutti hai. So Monday is the 7th of July. That's awesome. And so I hope to see you guys, most of you guys, in the live session. And yes, you guys can DM me. But now I'm going to go because my team is waiting for me. We have to worka. Yeah? Sounds good, guys? I can't understand solid density writing. It's just highest. I've written highest here. I've written lower than solid but greater than gas, and I've written lowest here. Sorry for my handwriting, but I was also speaking. And you guys can rewatch the recording if you can't understand this handwriting, yeah? Because I'm also saying it. Mondays are not off. Monday is on. Monday to Thursday classes, but Monday is the 7th of July. So officially we'll be only taking the registered kids from Monday onwards. Sound good, guys? Sound good? Love you all. Where do we get the recordings? All the recordings are available on Carboxyl. Only these recordings have been uploaded, and this one will also be uploaded. All the other recordings are gonna only be uploaded onto the portal, which for which only the registered students are gonna get the access. Sounds good, guys? You can't access the portal until you're not registered. Okay, bye. Love you. Bye. Bye. Ciao, guys. Keep on spreading the word. Bye, guys.